This is the Amp Hour Podcast, released September 4th, 2023, episode 645, Moving Down the Stack with Scott Williams. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And I'm Scott Williams from Zentronics.
Welcome back, Scott. We had you on the show on episode 624, so it's only been about 6 months, but I'm glad you're back.
Yeah, thanks for having me back, Chris. It's been a while. A lot of things not too many things have changed, but enough to maybe talk about some more technical details and some updates on the business and also how things are going your side.
Yeah. Oh, well, I don't matter. Come on now. I think so. Last time, I was re-listening today, and you and Dave. So I had been following your posts. I don't even remember how you came into my purview, but I follow your LinkedIn post, and I had talked to Dave about it. And I said, Dave, there's this guy Scott. He's a young engineer out of Australia. He's doing this awesome work, and you had like these like super engaging LinkedIn posts about like just the work you're doing at RF testing labs and your other stuff. And I thought that was, I mean, obviously I was following along for that sort of thing, but then I started looking into your business and introduced you to Dave, and you and him talked about your consulting business. Can you give us a quick recap of what that episode was about?
Yeah, so I guess it was a great chat with Dave around running a consultancy or design company, and what it's like working with clients. Very different backgrounds. Clients have a lot of different expectations, different projects. Some projects are just doing layout if you're a real hardware focused person starting out, versus once you've got a team behind you, 4 or 5, or like us, 7 or 8 people, you're dealing with much bigger projects, much bigger programs, cross-discipline work, working with mechanical engineers, software engineers in the cloud, embedded engineers. So as a hardware designer, your perspective has to change a lot. And what goes into, I guess, even parts of the project that some people don't see, designing test fixtures and regulatory testing and some of the challenges there that, again, if you are in a larger company, you don't really see a lot of that stuff. You can kind of be abstracted from it. So it was good to share some of that with Dave, and even him coming from a testing and manufacturing background, even he had some good insights to share as well.
Yeah, and well, that actually gives us a small insight into the update of your company. So last time you said 6 on the show, and now you're at 8. Is that right? 8 people.
Yeah. Now we are, and it's a growth pattern. I don't want to keep going too crazy on.
Exponential, right?
Yeah.
Another 6 months and you'll be at 16, and then we'll be, then you're the biggest thing in Australia.
Look, it's growing a consultancy. It's probably one of the hardest businesses to scale because you're just selling time. So if you want to double the amount of people, you literally need double the amount of projects, double the amount of management, double the amount of meetings, double the amount of space. It's not something where you're selling a software product or even you're selling a hardware product. You can use contract manufacturers, contract warehousing, contract marketing. Yeah, right, exactly. So whereas a consultancy, you're not using robots, you're literally using people and using expertise. So it's we're keen to stay where we are for a bit, for probably the next 12 months, and really, refine our process and improve how we, document and go through projects and just make it more valuable.
Awesome. Yeah. And so we're going to talk a little bit more technical side of things today, although I probably should have been there for the last one when, I don't think Dave's been a consultant in a long time. So that's great. I like talking technical stuff too. So that's wonderful. I am curious about last time you had said, I still get to do technical stuff. Is that still the case? And then because I talk to people who start consultancies. I know a lot of consultants. I'm excited to talk to consultants. And one of my biggest fears is that if I was to be a consultant and to grow, that basically my stuff would keep getting whittled further and further down, and then I'd see my bench, one day a month. So how often, Scott, are you at your bench?
It's a great question.
I mean, actually, you're recording at your bench, so you're at least at your bench now. So that's good.
That's true. I'm in the lab recording as I speak. So look, it's a really great question. I think what it comes down to is you have to take trade-offs, right? So you can't actually have it all. You could have all of it, but you'd have no personal life, right? I just work 38-hour
Sure.
week.
Right.
I've got a great balance. I'm not like that
Nice.
business
Nice.
owner who's
Yeah.
cramming and staying up late. If I really went full time into management, so if I was constantly improving our process, doing one-on-ones with people, reviewing designs, just focusing on that purely and not actually doing my own projects or being technical, we could probably be even more profitable. We could probably do even more projects. We could be even more efficient, but I select to not do that much management so I can still, explore my passion, stay technically relevant, upskill myself, and have, again, my own little solo projects that I'm working on. Even with some of our biggest clients, those are the ones I usually take on. So they have that
Yeah.
real custom hands-on service from the person they met at the start of the engagement, right? Rather than
Yeah. Yeah.
just talking to the client and passing it on to someone else to do.
Yeah.
But what that means is, my time is valuable, right? So let's say running the consultancy, my time is worth whatever, $300 an hour. Because I'm the
Mhm.
manager, I'm helping people move forward. I'm unblocking issues. I'm talking to clients. But if I'm only uh, billing our hourly rate at whatever, let's say an example of $200 an hour,
Mhm.
then if I'm doing a project, I'm actually losing money that I could be
That's
making
right.
by
Yeah.
doing
Yeah. Yeah.
management. But I choose to do that because I want to stay hands on and I want to
Right.
explore my
Right.
passion. Right. That's what started it out. Starting it out. All I wanted to do was layout. I just love
Yeah.
PCB layout, not even architecture, not even schematics. But now it's trying to broaden those skill sets that I have as well.
Okay. So what's on your bench these days? I mean, whatever you're allowed to talk about. Obviously, there's always sensitivity there, but what are you
No,
cranking on?
yeah. So I think one of the one of the most interesting ones we're doing now is, so in Victoria, which is our state, we're introducing a um, we're introducing a 10 cents rebate if you return cans and bottles to like
Oh,
or an authorized collector. So it's kind of a
yeah.
recycling incentive. Now, Australia's actually had this for about 20 years. Ever since I was a kid, they had it on the
Yeah.
bottles, 10 cents rebate, but it was only in one of the states, South Australia.
I feel like it's
Over the
always
last,
you always say it's not just a rebate, it's a deposit. That's the big switch over because at least in where I grew up, you paid that when you bought, right? You're basically
good point. Yeah,
pushing
good
that
point.
externality up front. Yeah.
That's a good point, actually, right?
Yeah.
Because yeah, there
Yeah.
will be an economic impact whether you realize
Yeah.
it or not.
That's right.
Um,
Yeah.
so, so it's all about perception, right? Uh,
Mm-hmm.
so again, we're talking businessy here, but just to get the idea of the project, that's the premise. And over the last 20 years, each state has slowly brought it online.
Mm-hmm.
And Victoria, where we are, despite being a state with a lot of innovation, education, and quite a progressive state, it's actually the last state to ramp it on, funnily enough. So we have a client we're working with who wants to set up that a system for doing that counting of the containers automatically. You'd think it would be
Mm-hmm.
something that kind of exists, and obviously it does, right? There's Walmarts, I
Sure.
think, even in America, that there's hundreds
Yeah.
of people lined up with trolleys full of
Crunching the bottles.
containers.
Yeah. 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 Right.
Right, but what those systems usually are is they're more of like a reverse vending machine. And there's
Uh-huh.
companies out there that have those established, but that's sort of one at a time, one bottle, two bottles, three bottles, four bottles. On the other extreme end, there's probably industrial engineering companies that could set up a factory to do it at thousands of bottles per minute, pumping them through. But there's nothing really out there off the shelf that's kind of in the middle. So it could be people coming to bring their bottles, but being able to throw in, let's say 100 bottles a minute, something like that. So quite fast, being able to deposit it, a way to return the money to
Yeah.
them, a way to track it, a way to
Yeah.
put that information into a database. So we're actually developing a custom system for that at the moment. So it's quite interesting
Neat.
because there's custom electronics. There's ways we need to adapt the sensors into a Raspberry Pi or whatever the embedded computer
Mm-hmm.
we choose. We need a way to ensure there's strong internet signal. We're not just going to use the factory's Wi-Fi. That's probably unreliable. So we might add 4G into it. So it's a standalone
Mm-hmm.
little network. There's obviously buttons and a keyboard and a display that shows the count, so the user can kind of see the counts going up and get the feedback from it. So it's a cool little project where it's kind of systems integration, but still custom electronics, custom software, IoT. So it is an IoT device, right? It's connected to the
Yeah.
internet.
Sure.
We'll integrate it into a platform. So that one's pretty cool, and it's kind of a
Yeah. That's
green
great.
initiative that we're being a part of, which is always great.
Cool. That's a good one. That's a good one. What about broadly, kind of in the office? Are you seeing other kind of target areas? I mean, there's kind of these generally things that are focused on the ecology and kind of where
Absolutely.
environment meets economy sort of thing. But are there other areas?
Sustainability, yeah, yeah,
That's the word.
absolutely.
Yeah,
So,
sustainability. Yeah.
yeah, yeah, absolutely. So, a couple of other examples. These are ones that have come on and off in the last year or two, or we're still working on them now. One is like a bin sensor, so just for monitoring the height of bins. It's been done hundreds of times. It's a little PCB in an enclosure. You slap it on the lid of the bin facing down. It'll have some sort of sensor, which you could use ultrasonic, you could use laser, you could use lidar, whatever you like, and it just does a distance measurement to see how full is the bin. Some of them also use weight to determine, is it full based on weight? But obviously, if it's quite light rubbish like this sort of stuff, bubble wrap and styrofoam, the weight is not
Right.
a good
Volume
indicator.
density is not necessarily fullness, right?
Right, exactly. So we
Yeah.
were involved in one where we, sort of developed that basic distance measurement. It uses
Cool.
NB-IoT, connect to the cloud. Sort of didn't take off because that's problem has been solved by pretty readily available solutions off the shelf that you can kind of just
Mhm.
integrate. But
Yeah.
that's one we got involved in. That was good. Another one is more in the renewable space. So um, designing some, I kind of have to talk high level, but designing for hydrogen cells.
Oh,
Some like
interesting.
monitor some PCBs that will live inside the hydrogen cell and monitor the kind of the health, the temperature, some basic things like that. So these PCBs will be embedded inside of them for years and years and years, working in quite high temperature environments, quite high voltage environments, which is quite interesting. So yeah, there's a lot of I suppose innovation in the renewable sustainability, and even just using technology to track. I think there's an acronym. I always forget what it stands for. ECG. Um, I always get it confused, or I can't remember what it's called. It's like your environmental
Uh,
coefficient or something. It's
yeah, I heard
basically
that
your
one. Yeah.
business. It's your business and how its environmental impact.
Mm. Yeah.
Yeah,
Yeah.
ESG. I think. Sorry, ESG.
ESG. Yeah.
Um,
Okay. Cool. Yeah.
it stands for environmental, social, and governance. So
Mm. Yeah.
there's not really exact systems on how to track these sort of things at the moment. I think there's no exact standards, but businesses are trying to look at, okay, our fleet of vehicles, how can we track how much fuel they're consuming, and are they taking the most efficient route, and are they using X amount of CO2, or are we using electric vehicles now so we can say we've had a bit of a positive impact. There's a lot of technology development in that space, and it's cool to be a part of some of it. Yeah.
Yeah, if that's driving investment for sure. I mean,
Mm.
do you see stuff? I'm not sure about where you guys are, but like industrial driving stuff as well. Like, I mean, obviously there's the sustainability side, but what about like industrial, medical? What do you kind of what are some focus areas there?
Yeah, I think it's cool because we've got quite an even split. We've got stuff from industrial, like you saw on our website. One of our longest term clients is SiteHive. They're a company based in Sydney, and they're about as industrial as it gets. They have a device that gets deployed on construction sites for environmental monitoring. So kind of like noise levels, dust levels,
Mm,
vibration, all that sort of information. And we've been a part of their journey for many years now, and they're on 300 or 400 construction sites around Australia and New Zealand. And that's an example there where that we have that real strong industrial client base, but then we also do even consumer goods, consumer products. Um, and yeah, look, there's innovation all around the place, especially at the moment. I kind of expected with the way the economy is in Australia. With there's been, I think the states is similar. There has been a kind of an inflation issues the last 12 to 18 months. Now the interest rate has kind of tracked that from our Reserve Bank to increase it, and that means there's a lot less investment, cash available for investment. And that applies to startups and venture capital sort of spaces, but also to established businesses. Most established businesses, to do heavy R&D, they need to take loans, they need to seek
yeah,
extra
right.
investment. But we've seen incredible growth and continued innovation across the board.
So one thing that stood out from when you and Dave spoke was like you mentioned
Mm.
that you like to be able to have kind of full, not full control, but like to basically be like an outsourced engineering group. So when someone like SiteHive or these bin management and rebate things, like
Mm.
where do you start? Where do you start there, like as a team or like you personally, like what's the first prototyping thing you pull off your shelf? This is assuming,
Mm.
let's just take the money side out of it, right? So assuming
Of
this
course,
is
of
like a
course.
fully funded, they're like, Scott, I heard you in the amp hour. I believe in every single thing that you
We need to
do.
get this. We need to get this
Just
done,
blank
whatever
check.
it's going to take.
Let's get it
Yeah,
done. Yeah. So yeah.
totally. So I think from a technical standpoint, and this is great because even though I don't get to be the one designing the board or whatever in every project now, because that's just not possible, and I've got a great, talented hardware team behind me, unless there's another senior on the project, like a real high up senior, which we do have in house, but if it's me sort of help working with a junior or mid tier engineer, I'm always there at the start to kind of choose, all right, what's the path we take and sort of set them on that path. One clear thing we do at the start is basically, is it either out of our capabilities? So is it like FPGA space or medical space or something like that? So if that's the case, turn them away. And the next step
I
is
feel like
really, okay.
you're stalling here, Scott. Just what is your board? What is your board? What's your go to?
No, no, no. Well, I'm saying there's three things. There's that one there. So if it's
Okay. All
FPGA
right.
space, we
Outside.
have
So
no.
is it not an FPGA? We're gonna do it by elimination. Yeah.
Yeah, right. You got it. And then it's basically either, is it going to be a computer platform, so like a
Yeah.
Linux based platform, or it could be
Right.
Windows, but if it's just a computer based platform, so that might be, okay, it's going to have a camera, it's got to have a display. And these are things that micros can do now. Like you've seen the ESP32 with a camera and with a display. Doesn't mean it should be doing that though. Just because it can handle the data processing doesn't mean it should. Or is it more of a node sensor control system, basic inputs and outputs? And then we can basically go down that path of, all right, it's going to be a microcontroller based system or product, or a microprocessor or computer or whatever term you want to
Yeah.
use platform.
Got it.
Some projects are kind of a mix, of course. Like some might have a master thing with peripherals,
Yeah.
but you would
Right.
then
Right.
you would
Right.
then call that a hybrid project. But that's something at the start we do, and then we just use kind of the pretty standard industry prototyping platforms. So for those computer based projects, the classic Raspberry Pi. I mean, let's
Sure.
be real.
Sure. Yeah.
We've got hundreds, if not even thousands, of projects that now are out there using Pi compute
Yeah.
modules. I was
Sure.
one of the, I was using the compute module, designing the footprint for the two connectors before it was even available, just looking at the data sheet and working it out. So we've been using those for a long time, the compute module 4s specifically.
Okay. You didn't use it
So
in
there's no,
the SODIMM, like the old memory form factor, the
well, I
CM3s.
was like a uni student grad then, 2018, 2019
Yeah.
era.
Yeah.
So 2020, when the Compute Module 4 came out, that's when I was freelancing by then. And yeah, look,
Yeah.
basically used that a lot. Nothing wrong with it, right? I mean, the Raspberry Pi in its B form factor or A form
Mm.
factor for the 1 and 2 generation kind of got some flack for that. And obviously using an SD card is always, oh, it's so unreliable and blah, blah,
Yeah.
blah. If you turn off the power, it'll corrupt it, which, we've never seen that actually
They-
happen. It's
They're
just
not
anecdotal.
wrong. They're not wrong.
Yeah,
No, I've
yeah,
seen it happen.
yeah,
Yeah. It's
yeah.
yeah.
But nonetheless, right? If you manage the product around that, you're just choosing trade offs, like I was sort of saying before.
Sure.
Trade offs
Sure.
is what it's all about.
Yeah.
But with the Compute Module 4, you've got eMMC memory, you've got a very reliable form factor, industrial grade components. So there's nothing wrong
How
with
do you
using a
get the
Compute Module
connectors?
4.
Those Hiroshi connectors are unobtainium for me. I feel like that's like, I've gotten them, but like that's like my nightmare. Is actually like first it was the CM4s.
So
This is all
funny.
during the shortage,
So
and then like
funny. I
yeah, Hiroshi's
no,
they're
so
tough.
let me tell you. Now we're getting technical.
Yeah, yeah,
So when the Compute Module 4 came out, those were in stock fine. But this was around the part shortage time. When the Compute Module 4
sure.
came out, it was
Yeah,
late
like early.
2020. It was like,
Yep.
this is probably going to become a part shortage issue. I saw those Hiroshi, however you pronounce it,
Yeah.
high rose Hiroshi, whatever connectors, and they were heaps in stock. I bought, I think, not hoarding. I just knew that there would be a pipeline of projects. Right. I bought
Man, you
probably.
could have funded the company
I
based on
bought.
this.
I bought no. I bought like 200 of them. So 200.
Oh, okay, all right. That's not bad. Yeah, yeah.
Right, right.
That's not hoarding.
That's nothing.
That's
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 enough.
that's
That's
prudence.
enough
That's
for
prudence.
that's right. That's enough for 5 to 10 prototypes
Yeah,
per version per project for like
perfect.
10 version projects or 10, 20
Yeah.
version projects, whatever you want to call it. So, but
For
then
me,
you're
for
not
me, that would
wrong.
actually last a lot
Mm.
less because of the number of those connectors that I've melted using hot air.
Oh no, don't use hot air.
I have I know
You
that was what I learned that. Yeah, they don't
you
like
need to
hot
use
air
a
at all.
reflow oven, and a little
Yeah.
tip: you need to use uh,
No,
point
I just
point oh eight
drag.
stencils with those. Do not use
I just drag
point
solder
0.1
at this
thick or
point.
point 0.12
If I'm
thick
reworking those
stencils.
things, I just rip them off and then I drag solder the new ones. Oh yeah, no, I've gotten very good at that luckily. But yeah,
um, but look, you're not wrong. That was a serious problem when projects would then go to production. So obviously, I talked with Dave about a bit about this. So when production comes around, we don't offer the turnkey service. I don't like to be a manufacturer. There's a lot of warranty and liability and complications that go along with doing that once you're established. So instead, we work with the manufacturer. But as you predicted, as soon as we would transfer a Raspberry Pi Compute Module 4 design into manufacture, first thing that would come back, we can't get these Hiroshi connectors. This is, early 2021 to early mid 2022. And yeah, look, we would just have to scour suppliers. So even using like LinkedIn network and getting support from other people in industry or whatever, forums, like, do they want to have a source for these? I've been through that. And we would then supply those components FIA free and aid to those manufacturers so they could continue with the build. So there's always these things that come up. And it can be tricky explaining that to a client, right? Because they're like, what do you mean? You've designed this board. I've paid you X tens of thousands of dollars or whatever
yeah,
to
right, right,
design
right.
this product and develop all the software and do all the firmware, whatever. And you're telling me it can't be manufactured because that's technically true, right?
Did you feel the pull to go down the stack to go like, all right, well, I'll go get another module, I'll do my own like build root Reacto, because one of the things that I feel like we're leaning on here
Mm,
is like the build systems that are like built for these boards that is pretty
mm,
widely supported. Not like a Linux dev board is not that uncommon, but
no.
one thing that I lean on personally is like, well, a lot of community based support, and then also the
The
build
hardware
that are pre-built.
platform with,
Yeah.
yeah, exactly. Or
Well,
even just the hardware
really
platform.
specifically
Mm,
the hardware, the software that's built for the hardware, right? So like
yeah, correct.
having the device tree and all the Linux stuff that's already built for that specific hardware.
Yeah, I mean, of course, that's always been a thought in my mind. But see, being a consultancy, when you're an internal company, you you sometimes don't realize how many engineering hours goes into doing something like that, doing a project like that, laying out DDR RAM and a CPU and all of
Yeah.
the grunt effort. There needs to be a really good business case for that.
Right. Yeah.
Well, no,
Yeah.
there needs to be a decent business case if you're doing it with an internal engineer who's sitting there. You're paying them $100,000 a year. They're a bit quiet at the moment, or this project isn't the only project we need to get done. Let's focus on it. Let's do what we need to do. So it makes sense there. But when you're using a consultancy, if the difference between a Pi that just you put connectors on and
Yeah. Effectively
it
off the
kind of
shelf. Yep.
works,
Yep. Yep.
right? Effectively off the shelf, just some integration challenges that can come up. Which, and let's say there's X% risk associated with that versus going through a full custom compute module, or whether it's a module you design and then plonk it on to de-risk it, or if you just put it straight on the
Sure.
board.
Yeah.
The engineering hours, the extra prototype revisions, the risks, even like the spec of the board has to increase, right? Now, so now probably needs to use
Right.
micro
Right. Line
vias,
impurities and
more
yep. Yep.
control,
Yep.
different controlled
Totally.
impedances. So
Yep.
from in a consulting environment, unless you're working with like a government or like a utility vendor or something crazy where they're, or
How deep
medical as
are
well,
your
of course.
pockets, client?
Like,
Yeah, no, you're right. And like, and
will you
also
pay
like,
us
what are
6
their
months just to develop this thing that's already
right?
out there?
Yeah.
We just need to make it for this application because of these reasons.
Yeah.
It's
Yeah.
great if you can do that. I'd love to be able to do that, but I've never designed a single board computer because I've always worked in consulting, and it's always very hard to justify. Not to say it never gets done, but again, it's
Yeah.
usually those medical, high grade
Right.
industrial, very high volume kind of projects. So yeah,
Yeah, I think about the alternative suppliers too. Like, so I've kind of gone down this path a little bit, and like
Mm.
obviously there are other off the shelf vendors, but then it
Yep.
becomes more of a software firmware exercise where it's, again, like I said, build, root, Yocto, that sort of thing. And
Correct.
again, like you said, like you're saying, it's like, how much do I want to lean into this, and try and explain it too, depending on where your client is and their knowledge. If they're just like, I just need a camera, well, okay, well, let me tell you a couple things here.
Oh my god,
Not exactly.
cameras. Oh my god, the amount of like just clients who want like a baby monitor and we want a camera to make it that point of difference to other baby monitors. Oh, well, you don't
Yeah.
even realize how much more complex that little
Yeah.
baby
Right.
monitor now needs to be, right? Like
Yeah.
it's not just a micro with a RF radio and a crappy 8-bit digital mic anymore. It's a whole
Yeah.
nother beast if you've got a camera in it now.
Right.
Yeah.
Right. And one thing that's interesting to me is like looking at like the sourcing that happens. I'm really surprised if you look at like camera interfaces that
Mm,
there is standardization in that. There's like what MIPI is like one of the
yeah,
things, and like,
kind of.
yeah, so
Yeah,
like I don't
exactly.
really do it myself, but like I've never found enough of a standard interface where I'm like, oh, I
No,
feel comfortable that I
except
can
USB,
have
except USB webcams.
USB for
Exactly
sure.
right.
Yeah, sure,
Yeah,
sure.
exactly.
Yeah,
So I went through this pain. This was like pre-compute module 4. Like I wanted to
hmm,
develop this product for the client. So this is a pretty cool product. It was one that imagine a dash cam. Yeah. So imagine a dash cam sits in your car. You guys have these in the US a lot. I think we have them here. There's like YouTube
yeah.
channels in Australia called Dash Cam Owners
Oh
Australia,
yeah,
and every week
yeah.
there's all these videos that get uploaded.
Aussie man,
Great stuff.
Aussie man. You
Yeah,
watch that YouTube
exactly.
channel?
No, I don't. I don't. But
He's a
I,
brash
I
guy
will
from
have
Perth
to add it
who
to my
does a lot of.
list.
Oh,
Yeah.
it's fantastic. One of my
Oh, Perth.
favorites.
Perth is a
I know
far
it's the other side
long
of the
way
world for
away.
you guys, right? Yeah, totally, totally. It's like
um,
Californians for me, like basically aliens.
um, just remember, other people are listening to this, so we gotta.
Oh, right. I mean, I love California, and I definitely work for a company based out of California, so wonderful place.
Yep.
They're all aliens.
Um, so back to this project, right? So this
Yeah,
this
yeah,
this dash cam, but imagine it has a not just a FPGA that pulls data from the camera and puts it on an SD card. It actually has a processor on it that's going to run some programs and do processing. So on the edge processing. It has 4G modem inbuilt, so it's basically like a phone. Like it had a 4G
yeah.
modem in there. It had a display to show what was
Mm.
happening on the
Yeah.
module. It had a camera.
I will say one of the worst things to ever happen to consultants is the iPhone, right? Where they hold up, they
Oh my
say like,
god,
well, they cost $1,200,
this
$1,400
is
now,
this
but
is
they
twelve
hold it
hundred
up and they say
bucks. Like,
$600. This is like back in the iPhone 5 days. They'd be like, "This is $600. Why can't you just build this?" And I'd be like, "Do you know how much like high paid engineering effort when it, like, and just like the gobs and gobs of people, and yeah,
uh,
yeah." So I can see Scott's face right now. He's dragging on his face. He's yeah,
you
he knows his pain.
you said we wouldn't talk about too much business stuff, but this is client
This
management
isn't
business
business.
stuff.
This is just me
This
bitching
is
about
technical business.
clients.
Technical
Yeah,
business.
yeah, yeah,
Yeah.
yeah, yeah, yeah.
But look, it's so true, right? Like you don't even realize each year they would put hundreds of millions of R&D into it on top of building on prior IP. Yeah, yeah, on top of
Yep.
building on prior IP. That's the biggest thing, right?
On
They've
top
got
of
20 years of
on top of
IP that they're building
vendors
on.
that just drool and like come to them and say, "Here
We'll
you
design your
go,
camera
Apple.
module or whatever.
I will
Like, yeah,
do
exactly.
everything for you. Anything to get
Yeah.
on the bomb. Anything." Yeah. So
And then
we don't
and
do
then
that.
add to that this was the thing that blew my mind. We're getting really on a tangent here, but I need to share this. Like I thought the other day, how many employees does Apple actually have? And I thought it would be like
Uh,
some crazy, some reasonably big number. But I looked on LinkedIn,
mm,
which wouldn't even be
less than a hundred
accurate. It would
thousand.
be more than that,
Yeah.
right? On LinkedIn.
Uh,
They have
Probably.
almost 500,000 employees.
No, no, no. That's 500,000 have worked there, I think, on LinkedIn. So if you see, that's like basically people who have listed.
Okay.
Yeah, I don't
Right.
think.
Okay.
I think 500,000 have worked there, but no, I think less than 100. I think if you look at like the campuses and stuff like that, I think it's like
Okay.
100,000. I don't know. I'm sure they're
Still,
totally
100,000 is
disproportionate.
pretty crazy.
It's pretty big. They're a
a
$3 trillion
large
company,
city.
Scott.
Yeah,
Yeah,
yeah.
yeah. So there's a
Anyway,
lot of,
anyway,
yeah.
let's
But
wind
I
it back.
think
Let's wind it
one
back.
thing that always
Yeah.
like that's always hidden by that number. So say you even
Mm.
have 100,000 people, support, engineers, whatever, right?
Developers, engineers. Yep.
There's no they're not vertically integrated, right? They don't own
No,
Foxconn. How many people are working
no, no, no.
Foxconn? How many working all the, like, if you look at like
Absolutely.
all of the stuff, all of like the layers and layers and layers that go into an iPhone or
And
similar, it's
exactly
massive,
right.
right? I mean,
And like
Yeah.
exclusivity with chip vendors, so the lower side
Yeah.
of the chain, absolutely.
Yeah. Yeah, if you look at, like, the
Yeah,
6 layers of, Kevin Bacon equivalent in the electronics world, I don't know what that would be, but, like, how many
six
people,
degrees of
like,
6 degrees
yeah,
degrees of Kevin
the
Bacon.
the
Yeah.
the the maybe even just 2 to 3 degrees away from the iPhone, right? So, like, I used to work at
Mm.
Keithley Instruments. I didn't know it at
Yep.
the time, but I
Mm.
I I have been 2 or 3 layers removed from Apple stuff for a bunch of my career. So, like, Keithley used to
Mm.
supply the 2306, which was doing battery
Interesting.
testing for the iPhone.
Yep.
I got my first job at Samsung. I was working on flash memory that was getting put into some kind of, oh, I don't know, some kind of future device that's going to have lots and lots of storage on it. Like, no, that's going in iPhone or iPods, like it was all bad,
Absolutely.
in
Yep.
2006. Yeah. Like that was like it was basically the early iPhones. I
Mm.
was
Mm.
putting stuff into that. So like, yeah,
The technology stack is crazy. It's
yeah, you
crazy
just
to
think
think
about how many
about.
people are
So
touched by that industry, about the ecosystem, and it really touches a lot of different jobs and industries
yeah.
for sure.
Yep. And I mean, on the contrary, being a consultant nowadays is only possible because we have access to a pretty good network and pretty good technology
Totally.
stacks too. So with respect, there's
Yeah,
kind of, it
yeah,
goes both ways. But yeah, it is hard to justify sometimes to people the reality of technology and developing a custom product, one that you own IP around, that you can manufacture yourself from any manufacturer in the world, whatever it is, right? So this
yeah,
project, back to camera interfaces,
yeah,
getting
yeah,
back to that, right? This project, I wanted to just use like a Raspberry Pi camera because those are the things that you can buy off the shelf. They've got the lenses on them already. They've got the
yeah.
kind of mechanical design. Because usually, if you buy a camera sensor, you have to buy the sensor and put that on a board and design the optics around it. It's not
Right. Yep.
actually that trivial. But all the Raspberry Pi cameras are using the CSI interface. And I looked at all these alternative vendors, even for a custom PCB, like using an IMX8 or whatever from NXP. And like, you have to basically implement the CSI drivers yourself. It doesn't just plug and play like a Pi. The plug and play ability of the Pi is just crazily even undervalued beyond the community that still values it, right? And even working with a vendor of a compute module, like a competitor to the Raspberry Pi, asking them, hey, can your R&D department, if I buy 100 of them or 1,000 of them, can your R&D department
100.
write the CSI? And even they were like, no, we can't do that because it's just not possible. So it was camera interfaces are just crazy, just
No, it is
crazy to deal
interesting,
with.
like how those kind of things like drive decision making, right? Like so for example, when I'm designing stuff these days, granted, I, I have a very specific kind of like
Of
mission
course.
on my stuff,
Yeah.
but like I'm using Zephyr all the time. I don't design
Mm,
stuff in if it doesn't have a Zephyr driver personally, just
yep.
because like it
100%.
is not worth it to me. Like I could potentially go and write a Zephyr driver, but like there's no product differentiation in any of the things that I do because
Mm, mm-mm.
it's not like I'm not choosing based on specs really. It's just like, isn't it an accelerometer? Yeah, it's an accelerometer. It's in the Zephyr driver. I'm choosing that one, right? Like, how do you
Uh,
choose parts like
Well, the biggest one is reuse.
that? Okay,
From
sure.
a hardware perspective and a firmware perspective. So I mean, you're talking there around you're reusing other people's stuff or an open source community stuff. Same concept, but for us, it would be more reusing products and parts that we've used before. Uh,
Okay, sure.
that that saves time, but it's more around risk, right? The amount of times we've
Yeah.
been developing with you'll put down a micro and an SPI module
Yep.
and you'll lose 2 or 3 weeks on it because you find out it uses SPI with the polarity the other way around. And that's like a
Yeah,
setting you
right.
rarely ever go and change. And it's like
Yep.
all your readings are off by 1 bit. It's not like it's wrong. It's like they're all off by
Right.
1 bit
Right.
or
It's like
something
clocked
like
over by
that.
one. Yeah, totally. Yeah.
Right. So like just that's the sort of stuff we lose hundreds of hours on over a year. It's not
Yeah.
actually the solving the technical challenge. It's the drivers and
Yeah.
compatibility and
Yeah. It's like a
all of
leaky
that. So
bucket for money, basically, right?
absolutely, and you're right in that whether you're selecting a micro, whether you're selecting a temperature sensor, accelerometer, whatever it is, these hardware blocks we choose, unless it's something really specialized for that application, like for example, if we're designing something like this hydrogen cell thing, like the temperature sensor needs to go up to 200 degrees C. Good luck finding one of those, right?
Yeah.
That's not
Right.
actually that trivial, even though 200 degrees
Right.
C isn't that hot. It's not the temperature of the sun or anything like that.
Right.
If you're just designing a generic node or generic product, absolutely, we we would say, look, there's so many things that suit this need. If you filter the microcontrollers with this much RAM, this much flash, this package size, and this cost range, you'll still get thousands of results back usually, right? Like seriously, you'll get thousands of results from all the different vendors. So the most simple and pragmatic approach is choose something you're comfortable with, choose something you're familiar with.
Yeah, no, I think that's right. I think that's right. And I think one problem is like, so like that 200C thing that you mentioned, often it's like large scale economics that are so far outside. So like, whereas you and I might
Mm.
benefit from something that had been in an iPhone and got super commoditized, and that's how it got cheap. Like something that
Yes.
is super specialized, like a 200 degree C thing that might be going like downhole drilling, right? So it's like in
Yeah,
oil and
exactly.
gas thing, and then it's there's the physics of it, which are difficult and very
Mm.
very tough to make. But then they're selling
Mm.
into like a really high margin space as well. It's like, oh, I'm not able to afford it because I'm not designing for that space. So then it's just like you have to go to the client and be like, well, you're just gonna pay out the nose because you have this thing that the oil and
It's
gas
a niche
people think
requirement.
also have.
Yeah.
Yeah, exactly. Yeah, exactly.
Yeah. It's funny you say that because you'll find a lot of the times automotive rated products can be cheaper
Yeah,
than the
right.
non-automotive
Oh, wait,
counterpart,
really?
which is quite interesting. Yeah, because of
What's
the
an
high
example?
volume they're manufactured in. I can give you an example. You'll have
Okay.
to give
Because
me.
one thing I always
Yeah.
get, I've been super scared about anything automotive
Mm.
lately too, because so much of the shortages were driven by automotive, not driven by, but
Mm.
they swept up in is probably a better way to say it. And so that
Yes.
like, oh, Chris loses every time, right? Like if it's down to me or Ford Motor Company, like all of those parts are going to Ford Motor Company for as long as they say, right? They are just like they have gravitational pull that is way. I am a tiny pebble in the universe of silicon, and they are a planet. Ford Motor Company.
This is you're describing the last 2 years, right? I don't
Yeah,
think
right. Right.
I don't think little design houses and even
Mm.
reasonably sized manufacturers were the ones
Even
purchasing
But
reels
even
and reels of things.
DigiKey, right? Like DigiKey, Mauser, all these distributors that you and I buy from, right? Like, they were just like anything that maybe got cast off, but they were back of the line too. I feel like.
Well, that's the thing. You think it's not until you get into high volume manufacturer for a project you realize that a couple of thousand on DigiKey when you're a designer early or mid through your career, you're like, oh great, there's heaps there. It's like
Yeah, right.
actually this is high volume. If you've got 10 of those parts per board, right,
Yeah,
and you're making 100 or 1,000 boards,
100,000, 100,000.
DigiKey is not enough. Well,
Yeah,
but even
definitely.
I'm not even saying extremely high volume. I'm saying just
Oh, right, right,
reasonably
right.
high volume.
Got it, got
DigiKey
it.
is actually not enough volume, so you start buying reels from the
Oh, I
manufacturer,
see.
and
Got it. Yeah,
and
yeah,
you
yeah.
don't you
When are
don't
you
realize that
crossing that
last
Rubicon
yeah
of like, yeah, I've got so many parts that I'm like, I couldn't source this out of distribution if I
someone
tried, right?
called TI, yeah, exactly,
Yeah,
and you don't
brutal.
realize during the supply chain shortage, it wasn't DigiKey and all these weren't the leaky
Yeah,
tap. It was literally way above that is where the
way above.
reels were disappearing. Yeah, so
That's right. That's right. But they also
alas.
bought from DigiKey, which also hit you and I, so that, yeah.
Yeah, it's all right. We made it to the other side.
Okay,
Mm.
so yeah, automotive. You said you had an example.
Oh, I've asked one of my. I don't have the MPN on
Oh,
me,
you get
right?
okay.
But
Oh, no
but
problem.
it was like a 56 nanofarad cap, high voltage rated, like an X2
Okay.
capacitor, and it was
Oh,
one that
okay.
was automotive grade. Whether that's for the temperature, the
Yeah,
AEQ
yeah, yeah. Yep.
100 or whatever it is. I can't remember off the top of
No.
my head, but yeah, that one was literally cheaper in the automotive grade. So
Okay. All right.
again, trade off there with, like you said, you can pick the cheaper one, but you're choosing a trade off because there's a
Yeah.
risk of
Yeah.
supply chain, a higher risk of supply
Yeah.
chain.
Totally.
It's very
Oh man.
interesting. And this is technical stuff that you just, as a designer, you just don't feel like you should have to think about, but you actually do need to think about these things pretty
And you need to
significantly.
think like you mentioned in that last show too. It's like it affects you so late in the game that like I don't know.
Hmm.
If I could go back in time and tell my younger self to like make different decisions based on sourcing stuff, like oh man, like it would change entire
Architectures,
system architectures. Yeah, yeah. I would just be like, well,
mm,
you shouldn't do it that way.
100%,
That's a terrible idea because this is going to bite you this, and this, right? Yeah.
100%, absolutely.
Okay. So in a best case scenario, so you said like
Mm.
when you have these generic kind of and you mentioned kind of some of the examples you mentioned in the last episode as well. You mentioned some things that sometimes you're kind of turning the crank on these well specified things for clients,
Mhm.
but in your consultancy, in Zentronics specifically, what kind of shop are you? Are you what do you reach for microcontroller wise?
Ooh, yeah, I like this. So pretty much it's like ESP32 if it's a Wi-Fi
Sure.
application,
Yep.
Nordic if it's a Bluetooth
Bluetooth.
BLE
Yep.
application, and effectively anything else we go STM. So that's
Okay.
kind of us. That's kind of, again, we're not wedded to those. We make that very clear, right? You want to be tech agnostic as a consultancy. If you
Yeah.
start
Totally.
selecting X or Y component because only because you're comfortable with it, or only because you've used it before, the amount of times I've seen people, like even other design house companies' designs that I might come across, whether it's because I'm networking or discussing with them or whatever, and they just throw compute modules on everything. And then you look like Raspberry Pi compute module 4s on everything, and then you look at it and they're not even using USB, HDMI, or camera. And you're
Yeah.
like, why are you doing that? Oh,
Is
well, we
it
have
like
a cloud
you guys
platform
you
that
guys
integrates
only
to it.
know Python?
So no, but seriously, like that's a serious. You're choosing a $60-$70 embedded computer, maybe even $100
Right.
Australian, over a $4.50, even
And
32-bit micro, even an 8-bit
right,
micro could
right.
probably do it. Now, no one's
Yeah.
perfect, right? We definitely use 32-bit $5 STMs when we could use a 50-cent SOT
Sure. Yeah.
23.6 little Chinese micro, but that's just
Yeah.
silly then. You're talking about development costs is more than the material cost over the volume. The
Yeah.
economics don't
Yeah.
add up there because we would spend a year working out how to use that new micro platform.
Yeah.
But
Well, it's like EVT, DVT, PVT, right? I mean, I feel like you should almost approach. So, like you mentioned, ESP32 for Wi-Fi, right? You will be able to get them up and going Wi-Fi almost immediately,
minutes.
right? Same thing, Bluetooth, STM32, whatever. Like those are, and even at STM32, it's got this huge thing. But if you already have dev boards that are, like an
Mm.
F4, or like, or you're always in F100 until you need to bump up, fine, whatever, who
Yep.
cares? Like that actually is the right choice for a client a lot of times because they're gonna be like, it's got a what in there? Depending on the
Yeah.
client, right? I feel like
Correct, right? And
yeah, yeah,
even that the reason this is the dark side to consulting is that the example of using a platform or choosing a component or whatever only because you're comfortable with it or only because you get leverage off of it, and then the client, because we could design in, say take an example, we could design in a compute module where a little $5 micro could go instead because we're using GPIOs and we want to run Python instead of C. It gets to production and gets quoted, and it's like double the price they expected. But like you could justify it and get your way out of it, like, oh, we use this component because of this reason. So there's like the clients are always at your whim a lot of the time.
yeah,
They don't have the
yeah,
technical
yeah, yeah.
ability to review your design and know what's in it. So we're pretty big on trying to stay as ethical as we can. And that's an example where that's actually an
Totally,
ethical
yeah,
question around what components you choose in your design. How crazy is that, right? That's technical
yeah.
ethics. It's nuts.
Yeah, no, I think it's good, and I think you're right too because well, I think it also ends up kind of feeding back over time too because
Mm.
they're not gonna probably be commercially successful with something like if they're trying to launch into like a like say you suggested a CM4 for something that's like going commercial, right, or like this
Yep.
consumer level thing, you're just not gonna be able
Mm.
to hit price points that might get replicated somewhere else, and okay, then you
100%.
just don't get the next job from them, and then you don't get add-on business. So I think it's in your own
Yep.
best interest to do that like the way you do. So what about okay, so client approaches you. All right, you're gonna
We've
choose an
chosen a platform.
STM32. Yeah.
Yep,
Well,
we've
okay, let's
chosen
just get
STM.
into it already,
Choose
right?
your hero.
STM32.
Choose your
Sure.
hero. Yep.
Choose your hero. Right.
Video
Yeah,
game
exactly.
style.
Yeah.
Yep.
Yeah. Uh, how often are you pushing them into a real-time operating system? I know it's always going to be it
Ah.
depends, but like, does your shop
Of
start
course.
from there, right? Because like you can also do a Blinky,
Yeah.
but then there's battery optimizations, whatever. So like,
Mm.
are you building internal enough systems that you're like, well, you just go with the Zentronics way, and there you go,
Yeah.
right?
Yep. Great question. Um, it's one that, it almost comes up every project. Like, what do we
Totally.
do
Yeah.
here? More and more, we're standardizing on RTOS for a couple of reasons. The first being that a lot of the time, if you start from RTOS from the start, the time difference for development isn't any more, any less. As long as you start from the start, you don't change halfway through the project because you realize you need an RTOS or you really want an RTOS. So that's one reason. There's almost no trade-off in time or development if you know what you're doing, if you're skilled with it. And fortunately, I haven't used it since university. I do a lot of firmware still, but Arduino to get a POC working, or some STM
Yeah.
HAL to get a whatever working. But our embedded engineers, they're very talented at that.
Yeah,
So
they
I
dig
can only
in
thank
and
them for
they
that.
just
Yeah,
right,
totally,
right.
totally.
Yeah.
They're getting stack overflows and heap overflows, and they're just, working through it constantly. There's always that side, but with a finite state machine approach, you'd still have those similar analogous issues. That's one reason. So there's no real development time difference. Second reason is if you have your boilerplates and templates and drivers established for that, then you save time compared to a state machine potentially, because you can have like example tasks for a driver, not just the driver itself, but even the example task that's doing the sampling, putting it in a queue, and you just can use that example queue. And then the third reason is a lot of times the application, if it's an application that, let's say an FSM, a finite state machine approach, or bare metal approach, whatever terminology you want to use, is more appropriate, and RTOS will still be probably fine. It probably will shoehorn into that fine.
Yeah,
On the contrary, if you've got an application that really should be an RTOS, so it's an STM, it's got an accelerometer, an SD card, a 4G modem, and it's constantly sampling the accelerometer, constantly writing to the SD card, constantly pulling from the SD card and putting it onto the modem before it sends the modem's file off. Good luck doing that in a finite state machine. You will not be able to do it. Even though in theory, the free RTOS isn't, it's still just C running. It still gets compiled down to machine code. It's not actually parallel processing. Good luck structuring it in a finite state machine.
Yeah.
So it's
almost a maintenance problem too, right? Yeah. So yeah, exactly. Yeah. I mean, like, how are you going to, I think also like when you get to the edge of the things, right? So it's like in the generic case, it doesn't matter all that much. But then like when you start to actually find a corner case, then I'm not saying that you can't get around it. It's just that it gets, the effort ramps quite a bit. And then you have to explain to a client, like you said, right? You have to explain to a client, like, well, we have to do it this way because of these decisions we made 2 years ago or whatever it is. It's just like, hey,
and exactly right. And I think if you have career aspirations to become, whether it's even just a manager, not just running your own consultancy, if you want to just be a great manager in a technical environment, being able to explain something like that to someone who doesn't have a clue about what you're talking about. So drawings, stories, examples, these are things that's a valuable skill to have. If you can have a client who doesn't know what a microcontroller is, you sit down with them for half an hour and explain why we have to invest twice as much time this way because of this way, using examples, and imagine this data goes from here to here, then what happens if this becomes constrained or blocked, or trying to translate that terminology in a simple way. That's such a valuable skill to have, right? Yeah. So yeah, RTOS all the way. Yeah.
Okay. I've been surprised. I don't know if I'm like being aloof or like jaded or what it is lately. Maybe it's also just like I'm in IoT, and like, I don't think there's many innovative problems anymore. You know what I mean? Like so like you said, like with the bin thing, right? So like I've made a trash can monitor pretty recently, right? Like these are things that like I'm just like, and my job is to make example designs that other people can copy. And like, I'm like, yeah, trash can monitor, I can make that one, right? And so like, I don't,
it's great that you say that,
think,
because like I know it's great that you say that, because it's not that the solution is novel. It's not that the concept for the solution is novel. It's the physical implementation of that. So the bin sensor. So it's a bin sensor. It has a $5 ultrasonic thing. It looks down, and it has a $5 micro, and it has a $10 4G modem in it, and that's it. It's just, it runs off a 3-volt battery. You don't even need a buck converter. You don't even need a linear regulator. You can just run it off the battery.
Yeah.
Super, super trivial. But no, what if the ultrasonic sensor gets dirty? What if what about ingress
Oh
protection?
yeah.
Is it going to be all
Yeah. No.
waterproofed?
Yeah. Yeah. Yeah.
How do you get signal inside of a metal bin? Because most bins, at least here in Australia, they're metal.
Oh, okay.
How do you remote
Yeah,
into
but
the
that's the
device? How
corner,
do you
right?
do
That's
firmware
the
updates over the
corner
air?
I'm talking
Yeah,
about. Yeah, yeah, yeah. And the
yeah.
corner is always the implementation and the execution is always the tough part. But the actual,
Integration.
I'm
Yeah.
actually talking about the so like when a customer comes, let's just say to me, I'm not going
Mm,
to say to you, right? So
mm.
the customer comes to me and they say, I need this thing. I'm like, yeah, it's not that. You know, they're like, I have this brilliant new idea. I'm like, really? I'm sitting here. I'm waiting. Please tell me your brilliant, this brilliant,
Yeah.
groundbreaking
And
idea. And then they
and
say
yeah.
bin monitor, right? And it's like, oh, yep, okay,
Yeah.
I can do that. Like, and it's tough. So, yeah, I'm not saying that I know everything because I definitely don't know everything. I
Mm,
have proven to myself over and over again. I'm
yeah.
just less surprised at the industries lately. I
Mm.
don't know if that makes sense.
Yeah, I mean, I think what we're seeing a shift in anyway is a lot more projects where we are integrating something. So we are, it's not that we're going to design a PCB that has a specialized sensor on it. It's this specialized sensor that's been made and refined and used, and we need to integrate to that. We need to learn how to communicate with that sensor, learn how to put it into our
Uh,
application, power it correctly. So there's a lot of things where it's like they'll have that problem is solved, and that again the bin sensor, but then there'll be some part of their problem like it needs to be ultra low cost because we're trying
yeah,
to beat
right.
our competitor, or it needs to last in Northern Territory. All the bin sensors in the Northern Territory where it gets to 45 degrees, they keep failing because the battery chemistry can't last that high of a
Yeah,
temperature.
right.
So that's where there is a lot of things where on face value, oh okay, another one we're working on, it's an automotive aftermarket product. It's a system where you can put it in your vehicle, and you can have the lights in your toolbox so that you open the lid and the lights turn on, and
Yeah,
you can
cool.
control your light bar on the front. Like, it's super basic. But again, it's all of these nodes scattered in the vehicle, and they all need to control their own logic, but also feedback to a motherboard that also
Mm,
verifies all of their states and make sure it's all safe. And, like there is always something we find. And if there's not, because there is times when it's not, it's literally like, oh, yeah, I pull up Google, show them like this has been solved before, and they go, oh, and they walk away, and we never speak from them again. That does
no
happen.
way,
That does
really?
happen. But
Oh wow.
yeah, yeah,
Because they
of
think it's a
course. I
novel
mean,
idea. They think they think the
yeah.
business is built on that. Ah,
Well, because they don't know the right terminology to look up. Like they don't know to use this particular name of
ah,
sensor, or this particular
okay.
type of battery, or this, or I say to them,
Interesting.
look, you
Yeah.
can't make it that cheap. It won't be possible
Yeah.
to make it
Yeah,
that cheap.
right. Right, right. Yeah.
Um,
Here's 100 other people that are doing it and the bottom of the range is $30. It's like you're probably not getting under $30,
yeah,
right?
no, right.
But
So
what if
yeah,
we
look,
just made it for
that
10?
always comes
Oh, okay.
up.
Yeah. No, that's
Yep.
interesting. How
Mm.
much so then in that like
Mm.
there's nothing really that different. I mean, like you said, the execution and the operational piece and the actual making of a thing, very non-trivial, like very difficult to
Mm.
do. But how much then in your company you mentioned templates? Are you guys like templating for this sort of thing? Or how do you try and offer
Yeah, I
something that's
mean,
like kind of not pre-made, but like ready to go? I mean,
yeah, it gets a bit blurry there, right? Because are we then like selling someone else's IP they paid us to make,
right,
and then
right.
just like
Exactly.
reusing it?
Yeah. Yeah.
I
Yeah.
mean, I asked this like years ago on Reddit or something. Um, it might have even been the consulting forum. I can't remember, but I asked this, and I was like, guys, like I'm not an IP lawyer, but like, are you sure we can just like reuse components between projects? And like all these people are just like, yeah, it's fine. Like, don't even ask about it. Like, let's get this
Oh,
straight. Novel IP is only around the whole solution. The pieces of the solution are just trivial. And I'm like, yeah, kinda. I mean, I could look at
well,
two
I would
client
never
products,
like.
and
I mean,
they're
you're
the
never like
same.
copying code, right? But like, you're saying like, are you
What
saying
about
like using the
drivers?
actual?
What about drivers?
Oh yeah,
What about
that's a good
logic?
point.
What about checking for a button? What about debouncing a button? There's
Yeah,
half an hour that went into debouncing that button on that project. Are we going to copy that block of while loop and just plonk it into this project?
I think you got to rewrite it. You
It's
got to
really
rewrite it every time. Or like do it yourself, right? I mean, or do it for your company and then either gift
yeah.
or sell that IP. But yeah, you're right. It's not like you said, it's not novel IP, but it is critical to moving stuff forward. And I just think from a personal perspective, I hate doing that stuff over and again. I don't know how to, yeah, I don't know how to solve that.
Yeah, it's interesting. It's a very tricky thing to navigate. I think one thing is, circuit blocks is something where if you look into a data sheet for any component, the block is there, right? So the block is there.
Right,
It's
right.
it's a buck in the middle. You've got the 1 microfarad
Yeah,
capacitor on the input. You've
prior
got the
art. Yeah.
right. You've got the two 10 microfarads on the output, the resistor divider. You calculate and you do.
Yeah.
That's given the data sheet. So that is definitely not novel IP. That's something that's there. But where the effort's gone into, the manual labor of putting that into our system, drawing the resistor,
Right,
putting it in,
right.
blah blah blah. But that's
See, the
no
way I
different
solve this
to
is that KiCad's actually terrible at reusable blocks. So I know Altium's great at it, but I can't do it. So
um I yeah. Well, look, the main thing is we avoid reusing. Well, no, we don't reuse entire blocks. We will reuse components, but not entire blocks, because from my perspective, even a buck converter, every application will use that buck converter slightly differently. Slightly different input voltage, slightly different output current requirements. So you would never just copy paste, both for ethical reasons, but also just engineering discipline and design notes and
right, right,
traceability. Where did you come up with that idea from? How did you design that in?
right.
So
Yeah.
but the actual main reason we don't have a lot of templates and things like that is because it can be hard to find time for it. If you're a successful business, you're
True.
growing,
True.
you're doing lots of work, you've got a backlog of work, which we do, right? We've got work for the rest of the year, which is fantastic.
Sure.
As a consultancy, being able to say that, that's nuts, right? A pipeline for 3 or 4 months as a 7-8 person business, you're very comfortable sitting there, right? But that means there is no time for that sort of. We do a lot of process improvement, continuous improvement, but templates is one that, well, I wouldn't say that's the highest priority. The higher priority for me would be project management, documentation,
Yeah.
employees and their lifestyle, making sure they have working from home setups and all the tools they need here, improving our lab, all of that stuff, right?
All those niceties, come on. No, crack that whip, man. Come on.
Get those
You're the boss.
templates. Get those
Yeah,
boilerplate.
exactly. Well, I
Yeah.
do think, I mean, there is like somewhere between, I feel like every dev shop eventually says like, well, we could make this a product, or we could make a product, or, like, there's always that like
Mhm.
push into
Yep.
but then I think the hard thing, so like Matt Liberty, who was on the show twice now,
Yes, I know, Matt.
he,
Yep.
yeah, he talked about it in depth of like, I literally saw the opportunity cost of like not billing for client work. And so you have to like basically assign your own thing. And then like he basically knows viscerally how much money he lost,
Yes.
opportunity wise. And then also like, so he's got to make that money back on the product. Then it's like, it's tough. So buy a jewel scope, everybody.
Yep. I've got mine here. Ready?
Yeah, I got mine too. I got mine. It's great. Nice.
Can
Nice.
you see
Yep.
the case? I think so.
I can.
Yeah, there
Yeah.
you go.
Oh
There's
yeah.
the
There you
logo.
go. Oh yeah. Yeah. Get the light. Yeah. Yeah.
Yep.
Yeah. No, Matt's great. Yeah, so it's tough. It's tough to make that switch though, like to switch into the product space.
It's interesting that being in consulting, I prefer that to having our own product, just because I'm so passionate about the development and design work that's just what I want to be doing and just what I want my focus to be. Not marketing, not warehousing, not returns and customer support, and those things happen when people don't realize if you make your own product as opposed to just being a developer, you have all of these extra responsibilities, and they're responsibilities you have to fulfill. You can't just be like, oh, I'm not going to worry about returning calls to angry customers. Like, no,
Yeah,
you
right.
have to do that. Like,
Yeah, consumer commission actually eventually comes after you, right?
yeah, exactly.
Yeah, cool. What about other like tech stack stuff that you guys are doing internally? I mean, you'd mentioned like Nordic parts, ESP32, STM32. Any other things that you're kind of reaching for on a regular basis?
Yeah, we're kind of going through a process now, kind of evaluating IoT platforms. I think that's a big one where there's a lot of players in that space. So you've got the big guys, the AWS, you've got Azure, IoT Hub. You've got the very generic platforms like Things Board is one of them. And then you've got more niche specific ones like Goliath and whatnot, kind of tailor
Never heard
made
of
for
them.
that hardware. Trying to, make that, in quote marks, seamless integration from a hardware to the software.
Please, no selling, Scott. Come on.
But there's so many. Again, trying to explain this to someone not technical, there's so many hurdles with using and trade-offs with all of these. Like, if you go with the big guys, there's going to be there's going to be always new features, there's going to be always uptime, there's always going to be whatever. But as a customer, you are a tiny microbe compared to some of Microsoft's and Amazon's customers. You are not going to get the support you probably would hope for, versus some of these more niche platforms, more just specifically for IoT. Thingsboard, for example, we started using that on a project back in the early days, like I think two years ago or a year and a half ago, when we were starting out. I had one software guy and one firmware guy and me, like just three of us or whatever. And then Ukraine, the whole Ukraine-Russia thing happened, and Thingsboard is based in Ukraine. That was like, so that was like, oh, okay. We better move from this system to something else now, because who knows what's going to happen. So there's
a lot of great tech coming out of Ukraine for sure. Like Platform.io, I know as well. Thingsboard, I think.
Yep, maybe? Absolutely.
There's a couple. Yeah.
So look, we're going through that process now. I can't tell you which one we're using, trying to evaluate all of them through many different methods, and trying to find something that for us as a consultancy, again, we want to have something we can kind of package up and hand to the client once we're done our development, or we can co-develop with them on.
Right. Yep.
We don't want to be making a lot of companies, even design companies. I know there's one or two in Australia, even a lot bigger than us, but they have made their own platform, and you plug into that as a customer. But then, like, is that kind of like, oh yes, we'll design this, it'll be your product, your IP, but it's talking to our server and our platform, so you're kind of locked to us for the life of your product as well. Don't really want to go down that path.
Well, and then, like, so if you look at some of the IoT things that have failed, like that, usually it's like someone administering their own server, right? Which is a choice. But then, like, the company goes under or whatever, and it's like, oh, and now like the whole product's dead because of that too. So that's 100%. Also difficult, right? And that's where I feel like a lot of people are like, well, then I'll go to an AWS or an Azure because of just scale, right? I mean, like, I remember, I think when AWS IoT was announced, I think Dave had said, like, why would you go anywhere else? And like, fair enough, right? I mean, like, it's like, just from a scale perspective, like that does
exactly
like, lower
peace
risk,
of mind,
right?
and
like,
security. Exactly.
Nobody getting fired for buying IBM, right? So there are trade-offs there, for sure. Yeah.
And I mean, but even the big players, pretty fair to say 5 years ago, Google were a big player or reasonable player, and now their IoT platform shut down 12 months ago or whatever. So you don't really know. Like that, even Microsoft or AWS. Even Microsoft or AWS, they could shut down just those particular services. They don't have to shut down. Microsoft won't shut down, but the services they could just stop supporting, right? That's always a possibility. So we're going through that process now. We've got two software developers with us now, which is fantastic. Just no hardware, not embedded, just pure cloud IoT kind of platform space, because a lot more projects are demanding that now. And so they're kind of working through that as a bit of an internal project, which is great.
Yeah. Well, you had mentioned too, when you talked to Dave about, like, you kind of have people coming to you from, you said you didn't want to be like an internal, you said you didn't want to be like a layout group, but you did want to maybe be an engineering group. But then I feel like that then potentially determines, it always matters who you're talking to, like who your end customer is. So if your end customer is the software group, then often you're tied to like you're kind of tied to what they're tied to, right? But if your end customer is like what I call an operator, like so like someone running a car wash that wants a sensor node throughout their car wash or whatever, very trade example there, like they don't care what your stuff is, so they might be like, yeah, just hand us an app or a website, and that's all I really care about. So you get to choose then.
Yeah, and I think starting out in the big wide world as a freelancer with one oscilloscope and one crappy power supply in my apartment, I would have just, like I said to Dave, my door was open to anyone. If someone came to me and said, I want to make an X-ray machine, I would have just gone, yep, I'll give it a try. I'll give it a crack, no problem. Whereas now I'm more careful with that. But that's been an organic approach where I've just been like, all right, that kind of feels like a good fit, or kind of doesn't feel like a good fit. Or sometimes projects come along and it's like, oh, I was thinking of us specializing in that area a bit more. Let's take on the project and use that as an opportunity to learn more around BLE. Or let's use this project to learn more about power supplies and power electronics design, and send someone on a course for it before the project starts. And, that's kind of where it's been. And in terms of where our focus is, it certainly is not what, like you said, if you wanted to be a hardware company doing hardware design for software companies, that's a great niche. That's an awesome thing to get into. Personally, I found it really, really hard, because you would have a project, you'd have a board, You design it, it would come, you prototype it, blah, blah, blah. You'd verify that it's the ends of the earth, and then you hand it to the software company, and they say, "Oh, it's not working." They hand it back to you. You say, "Yeah, it's working." They say, and there's this back and
Right,
forth.
right, right. Yeah,
You can't beat having everyone who's technically involved in the same room.
yeah.
At least there's obviously boundaries. Like we don't do mechanical design, and
Sure.
that can be important. But we can always go to their office or send them the sample and get some feedback. But software, embedded, and hardware, those are just like this now for most products.
Yeah, yeah,
You
yeah,
just can't. The line is too blurry between them.
yeah.
You can't split them up.
Yeah, I think
Yeah.
you got to have like really good test documents. Otherwise, of like, no, this is how it's gonna go.
Oh,
This is how we're gonna
no,
validate it.
but then it
Yeah,
gets political. Then it gets
yeah.
political,
True,
right?
true,
It's
true,
not
true, true, true. Yeah,
you know what I mean? Like a table that
yeah,
has this company has to test this part of the project.
yeah. Right, right,
Like
right. And then
how
it's
about we
a lot
just
of
all
finger
work
pointing and
together and
yeah, yeah,
collaborate? Yeah,
yeah. It's tough. You get yourself
it
into
is.
a hell of an industry, Scott. Come on, man.
Industries plural, really. I guess the different.
Industries, yeah. That is
Yeah.
one thing that's interesting too. So I was actually thinking about so Colin Carpfinger, who was on the show, oh man, a long time ago
Mm,
now. He did punch through design, and
mm,
it's a consultancy, Minnesota and San Francisco, and they're still around,
yep.
but they are like Bluetooth. Like you want Bluetooth, you go
Yep.
to they are like Bluetooth, Bluetooth, Bluetooth. Like,
Yep.
and I think my I'm not gonna do what you do. Like if I'm a
Mm.
consultant, I'm a lone wolf. I'm hard to
Yeah.
tame.
That's that's what I said for nearly 2
Yeah, yeah,
years,
yeah.
but
Yeah,
yes,
yeah,
here I
yeah.
am.
I think one of the good thing about that punch through idea is that like you can really optimize, right? You have people that like, know the thing. They're like, yeah, we're just gonna turn the crank, turn the crank, turn the crank. I think about it, I'm
Totally.
like, that is so boring. But from a business perspective, that is the right call to do. But like, it's tough,
Absolutely.
right? I mean, like, yeah, it's
It
yeah,
just you just want to pick a market that has a high requirement for that sort of work, which Bluetooth is a
sure.
great one. I
Bluetooth's
wouldn't
great.
go and
Tons of
start a
Bluetooth.
design. Yeah, I wouldn't go and start a design consultancy specializing in. Oh, geez, I don't know, like something really. I can't think of anything really niche, but like ultra low power. Actually, no, that's a pretty good niche. I was going to say ultra low
Yeah, I
power
was gonna say
design,
it's pretty
but
good. Yeah. How about like only devices that communicate over RS-485, but only
yeah, right,
using right, like, we
totally.
only do Modbus. How about that? Like, we only do
Which
Modbus, nothing else.
20 years ago would be gold. Like companies would go to you
Yeah,
like,
actually would
we
be.
want to make a
Yeah,
temperature
yeah.
sensor for
Yeah.
this
Oh, you're
or
the
a SCADA
Modbus guys?
system
We love
for this or this.
Modbus. Yeah, yeah,
Right,
yeah.
right. Whereas now that's changed, of course, and Bluetooth, the same thing will happen in 30
You might
years.
be able to make a
Bluetooth
business
probably
out of
won't exist, but
yeah, true, true, true.
um, yeah.
Yeah, I guess what are some of the
So
other like smart home things? Like I guess Zigbee's still around with Z-Wave. Z-Wave, like starting a Z-Wave consultancy in 2023 would be a bad idea, I think.
yep,
Like it's still around.
agreed.
It's not bad actually, but it's not it is not
Yeah,
it's not hip. It's not going to be
no,
long it's not
no,
longevity, right?
no.
Okay. So Zentronics not into Z-Wave.
No, no, not into Z-Wave. Um,
Okay.
keep it general, and look back to the coming full circle to the start of the
Mhm.
conversation. Like
Yeah.
I've done, a bit of business coaching with coaches. I never really had like a mentor, so to speak, but just coaches that I've kind of paid and done courses and training with,
Yeah,
and
yeah.
they all say like specialize, specialize,
Specialize.
specialize.
You got to do it. Yeah.
Don't be the generalist. Don't be all things to all people. It's a nice rule to follow, but like at what level do you specialize and in what
Yeah,
industry? Like
right,
there's no
right.
such thing as just being a specialist. Like we are a specialist. We're a electronics development specialist, but
Mhm.
within electronics development,
In
we're not specialists
right,
in any
right, right.
particular field. So we are
Well, you
specialists.
said like
It's
in the
just
last
that
show too, you said you're effectively regional, even though you're not regional, right? But you've gotten business regionally. So like that's another
organically, yeah.
specialization that's not actually a specialization, right? It's like
Right.
these
Exactly.
categories you start to get into without being pigeonholed. So it's
Yeah.
tough.
Yeah. And years ago I nearly became a I sort of was for a few months there, just purely focusing on EMC, like literally
Oh yeah.
worked with the
Right.
test lab here in Melbourne and got them to any people that failed testing. I'd come in and review their design, and I would come to the
Mhm.
lab and help them get a pass and suggest filter designs and shielding techniques and all these things. And I'm a huge fan of Ken Wyatt, Keith Armstrong, Todd Hubing, all these guys who are gods in that space. And I've done all the training, even paid one-on-one for some mentoring time with them.
Oh, cool.
Really was fanatical around EMC and EMI for a few months there. And then I stood back and realized, hang on, I haven't designed a board myself in months. I'm going to start hating this pretty soon, because that's where it all comes from. It's just, I love designing boards. That's, just a passionate electronics engineer like a lot of us.
Yeah, and I guess if you did want to like super specialize, then you'd have to, in a similar way, like start teaching courses or things like it in order to, like in the
Right,
EMC
to make
space,
it
that sort of thing,
economical,
right?
or just your hourly rate goes from whatever 100 or 200 an hour to more like 400 or 500 an hour, which is fair enough, but that's because you're only working half as much billable time, right?
Yeah. I just don't have those skills. That helps for me. That's how I keep it fresh, Scott.
That's how you steer clear. Yeah, exactly.
Yeah.
Always learning. Always learning.
Got to keep learning. It's like like being a educational shark. If you stop learning, you die.
Exactly.
If you're swimming, I suppose. Really good. Mostly I make all my money on anecdotes during podcasts. That's how I make all my money, Scott.
Yep. If only.
Yeah. What about so you mentioned EMC stuff. I mean, are you still in the lab these days at all? Do you get to go back at all, or no?
Oh, so I mean, I guess different consultants have different experience in this, because again, like if you slot in at some point in a project, or like you're just the hardware guy or you're just the software guy, whatever it might be, you cannot get to see that whole project cycle. But like I talk with Dave, it's like, no, I kind of want to guide clients through that whole process. And that includes doing all the quoting and identifying what standards, talking with the test houses, arranging the testing, taking the sample for testing, writing the test procedures, all that sort of stuff. We do that whole service. We have, might not be me, me on and off. We'll have an engineer in the lab every week for a different project. There's just a constant churn through different projects, which is great. Not because we're going back because we're failing, because it's a new project going through testing. Obviously, there's always the occasional failure or whatever that you just can't predict. I said this to Dave. I said, the Dunning-Kruger effect. It's like if you don't know anything about EMC, you're probably worried about failing. If you've done a little bit of, I followed this grounding technique and I have filters on every line, I'm definitely going to pass this time. Then you're at the point where you think you know a lot, but you don't. And then if you know, again, I'm not going to say I'm an absolute expert, but I've been in the lab hundreds of times. I've put over 100 products through full compliance testing. You just can't predict with absolute certainty. There's so much with RF that the way the cable interacts with the chassis, the way the chassis interacts with the board, the way the clocks on the board interact with each other, the way the ground plane can be the thing radiating if you've got common mode currents across the board between the two connectors, right? Like that's the thing that can be, there's current flowing on the ground plane, right? So there's inductance on the ground plane. So you get a voltage difference on the two sides of the board, right? There's all these things that like you can do your best, but in a pragmatic product design where not every product can have a metal chassis, not every chassis can have 360-degree bonding to the connectors, and not every cable can be shielded, you're just not going to know. You're just not going to know. You can just have your best intent with all your design techniques to pass, great stack up design and having filters on all the power inputs and the signal outputs, but there's always going to be something that comes up.
What is the craziest failure you've ever seen there?
Yeah, there was one that was really, really tricky a few years ago. It was basically this big charging dock. And it would charge these little devices kind of the size of your finger, so you could fit maybe 10 of them on and charge them with kind of pogo pins sort of thing. And there was this failure that was across like a broad spectrum with radiated emissions. So conducted emissions pass, that's the noise going into the power point when it's charging. Even if it's powered off 12 volts, they'll still measure the plug pack, the noise coming through the plug pack like that. And that passed, and that can be quite common because if you've got a plug pack off the shelf, it has a heap of filtering in it. So it kind of doesn't give you a good idea of your product's emissions. It kind of shields and hides a lot of your noise problems that your product might have when you do conducted emissions testing. But the radiated emissions, of course, that's measuring the noise coming off the product, off the cables, off the internals, off the internal wiring, all those sort of things. So that product was failing radiated emissions quite badly. It had a Raspberry Pi. It had a couple other auxiliary boards scattered throughout it, sort of like for holding the pogo pins, and a bunch of power cables that ran to those. It also was running USB to all of those through like a USB hub. of course, we dived in and sort of looked at all the custom boards and saw what's the problem with these custom boards. Do we need to add filtering here or there? We had common mode chokes everywhere. We had, because that's for USB, because it's pseudo differential. It's not true differential. It doesn't go around 0 volts. It goes around 0 to 3.3. You want to have common mode chokes because the crossover is not exact, so that when it goes from high to low, the eye diagram, there's a bit of skew there. And when there's that skew, it means there'll be a common mode spike every time there's a transition. That's what causes a lot of noise. So you put a common mode choke there, solves it. All these measures, and then we spent about a week on it, and it was the USB hub, this industrial grade, like ultra compliant, all the labels, CE, all this. But then we did trace that back to just being not a like a DigiKey one, like a Alibaba one. Again, not specified by me, but I mean, I don't. you can believe it was specified by me, but this was when I was more of just the layout guy, just the EMC kind of specialist times. And yeah, that's what the failure came back to, and that just shows you there again trade off. You choose the cheap, low cost USB hub, it bites you in the bum 6 months down the track. So, and you can't predict. You can put all the filters you want on your boards. You can make the cable length short. You can use shielded cables everywhere. But if there's something like that, you don't know its noise profile. And even if you did, there's a chance that USB hub did pass its own testing. But in this configuration, with these cables and these boards, this enclosure,
right.
as a whole, the product can still fail.
Yeah.
You got it. Right, exactly.
Yeah, yeah, that's a good point.
Yeah.
Yeah, well, what are the, do you have any recommended, so you mentioned you do a lot of courses and stuff. What are your recommended courses for people to do that in that space?
For sure. So I did the I'm just going to get the right full name here. So this course is great for even if you're a mid or senior engineer, but you've never done formal training for design, because that's not something that really has ever existed, right? You can do the IPC courses, the CID ones. They're like pre-SMT days now. They're like the 90, late 80s, 90s standards.
Make sure
you're following.
Your actual capacitors are in this configuration. And
yeah. I mean, not even that level, unfortunately. But this one here, the PCEA educational one. So you can do this in the States. You can do this in Australia. I'm not sure about. I'm not sure about Europe and other countries, but that's one there. So a great one I recommend for just general design, even if you're a senior, even if you're a junior. It's some great content there. The book is like 1,000 pages, and then you go through a whole week course training for that. One I highly recommend for design for EMC is Todd Hubing's courses. So learnemc.com. He does a lot of great, like super fundamental stuff, like just if you've got, say, a digital data line. So that's for, like a UART line, and it's a TX pin. How do you, and you might want to put like some way to filter that before it leaves a board, because it'll have sharp edges on its frequency. Sure. Even if you're only doing 9600 board, there could be megahertz of content in that signal.
Yeah, right.
How do you filter that? Do you put a capacitor? Do you put a ferrite bead in series? Do you put a resistor in series? Do you do a combination of those? Some super basic stuff that a lot of people just copy what they saw on the reference or whatever.
Yeah, that's right.
A lot of times it's so wrong. Even the other day I was using a TI part, and it has the recommendation where it's like a SOIC 8 package, right? SOIC 8 package with the power pad underneath.
Yeah.
And it has, it recommends using a pore of ground on the top layer, and all of the currents go back through that pore, trying to keep like all of the return paths on the same sheet of copper. But that's actually like horrible advice to follow. You want to give those return paths the shortest path, the path of least inductance. And in that context, the path of least inductance is a via, as soon as they come out of the pins of the capacitor, of the resistor, whatever, a via down the 0.1 millimeters of pre-preg to the ground plane, and then a straight path back to the ground pin of the chip, right? You don't want to, there's all these things that Todd Hubing goes into, like, do not follow this advice. Here's some, not rules of thumb, but these are literally like calculations and theoretical statements you can follow.
Right.
And then of course, some of the best for other EMC design is Keith Armstrong as well. So he's, let me have a look here. Cherry Cloth Consultants. So he comes around to various different countries and does a lot of more formal training. So Todd Hubing's training's online. Very useful, very informative, like I said. But Keith is more of your traditional. He'll come and you get to spend a week really sitting with him, talking with him, workshopping with other engineers, and all of that. And then probably the last one that I really like working with is Ken Wyatt. His specialty is more training around troubleshooting, and once you've got a failure, what do you do about it? So that's obviously quite handy. Like I said, you can't, no matter what you know from those other guys, you can't predict 100% certainty you're going to pass in a real product design, right? If you have control over everything, you could, but in a real product design, even I talked to Dave about it, the plug pack. No one's going to design their own plug pack. So you put the plug back.
Well, like you said in the beginning of the show too, like you're as a consultant, you shouldn't be doing it, right? It's like actually irresponsible to do that.
That is unethical to do that. Absolutely. So yeah, there's some homework, I suppose.
Yeah. Okay. That's great. And actually, I was searching through links and stuff like that, and I saw someone on Reddit asked like, it was a month ago only. 2WOMT. I'm guessing that's a ham radio handle.
Yeah, ham radio handle. Yep.
Yeah. Apparently, we didn't ever put the link in for your Worth seminar that you mentioned 6 months ago. So we'll try and copy that in.
Yeah. That video is somewhere, so I'll look into that. And then, as I mentioned to you before, Chris, I've got a video coming up with Robert Ferenak for Devil Academy. Yeah. So nice. It was kind of tentative. Like he said, if I can't organize it in time, no pressure. I'm committing to it now by putting it out here.
Oh wow, saying it on the air. Yeah.
So, but that'll be a few months away. I have to prepare all the content. It's still a fresh idea, fresh conversation with him. Cool. But that'll be on DFM, which will be really cool. Yeah.
Awesome. Okay. Well, people keep an eye out there. Scott, thank you for coming back. Where should people find you online?
LinkedIn for sure. I mean, that's just an open platform.
That's
now,
how I found you. Yeah.
Yeah, exactly. I think I messaged you. I look back in the old days and like 3 years ago, I messaged you like, "Hey, Chris, I love the podcast."
You messaged
me?
I join the forum? I found you. No way.
No, it was me. It was me, legit.
It was you? Well, thanks for reaching out. I appriciate that. Yeah.
No, that's all right. Just a young, hungry kid.
Internet connections that just become people you get to know, and then that's how it happens, folks. It's
that's it.
The internet is our workplace. So that's how we all meet each other.
Exactly right.
All right, Scott, great chatting, and thanks for being back on the show. And I'm excited to see future things you do, like that upcoming thing with Robert.
Great. Thanks, Chris.